Good day viewers, welcome to Young Maths Academy. Today's class will be on modular arithmetic. I want you to follow through the class very well and see how we solve questions on modular arithmetic. This will be an introductory class on modular arithmetic. Okay, what is modular arithmetic? Let's start with that. What is modular arithmetic? What is modular arithmetic? Okay, modular arithmetic is an arithmetic process where integers are divided by a fixed modulus. It is an arithmetic that explains events that goes on and on, such as days of the week, the months in a year, and so on. Modular arithmetic is also known as the remainders arithmetic, also known as the clock arithmetic. And the remainder that we are to obtain in our problem is actually our answer, and that remainder, the highest it could be or the highest it may be, must be one lesser than the mode. Okay, let's go through this together. Let's start by saying let's start with this. You should know that the mode of 2 will take two values starting from 0 and it will reach 0 and 1. Our mode of 3 in this set, we have 0, 1, 2. Mode of 4, we have 0, 1, 2, 3. Just like this. We also make use of the clock to explain, to deal with modular arithmetic. Suppose I have, this is 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let this hand be here and let this hand be here. Okay, you know I said it's a circular arithmetic. It deals with an event that goes on and on, so we can make use of our clock to explain that. Okay, suppose we add 6 hours to 9. We know that this will read 10, 11, 12. That's 1, 2, 3, 4, 5, 6. It goes up to 3. Now, if I add 12 to this 9, if I add 12 hours here, it will come back to 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it gets back to 9. So it's a repetition. So if I add 24 to it, it gets back to 9 also, because 24 is just a multiple of 12. Okay, this with this we can quickly explain that also we make use of our number line. There are different methods in which we can solve our modular arithmetic. We have number line. We can use our number line system. We make use of the clock as well, and we make use of our normal binary operations. That is our addition, our subtraction, our division, and multiplication to work with modular arithmetic. So I will show you different ways in which we solve problems. Okay, let's start with this question. Just have to rub off the board. Okay, so we have this question just like this. Question solve this way. Let A be that 5 is congruent. So this sign is congruent sign, or you say equivalent. So we are saying 5 is congruent to what value? Let the value be x in mode 2, and let B be that let's say 5 is congruent to what value? Y in mode 3, and let's see B that 5, let's say that is 5, for example, is, or let me say it's 3 congruent to 5 in mode 3. Okay, with this problem, let's quickly solve this and see how we deal with modular arithmetic just this way. Okay, taking A, we are dealing with A now. Solution, we have that 5 is congruent to what in mode 2. What that simply means is that if I divide 5 by 2, what will be the remainder? The value here is always the remainder. the value here is always the remainder, and that is what we are concerned about here. So it means that if I divide 5 by 2, what will be the remainder? So we can go first just like that. So I will just say 2 in 5. 2 in 5 will give me 2, remainder what? Remainder 1. So I have my remainder, that is my x is 1 here. So I can say 5 is congruent to 1 in mode 2. I can simply say this. Okay, I can also make use of my number line. So make use of the number line now. Number line. I'll just draw this. Let this be 0, let this be 1, 2, 3, 4, and 5. Negative 1, negative 2, negative 3, negative 4. Okay, so I have this. For 0, 0, the number here, 0 maps to 0, just like that. 1, 1. In mode 2, we are dealing with what is 5 congruent to in mode 2. So 0, 1, this will also be 0, 1, 0, 1. So just like this also, this will be 1 because this is 0 already, 0, 1, 0, 1, and 0. Let this be another 5 here, 0, 1. Okay, good. So we check the values, what they are mapped to. 5 is mapped to what? 5 is mapped to 1. Good. 5 is mapped to 1. So we check which other value is mapped to 1. 3 is mapped to 1. 1 is mapped to 1. So it means that number lines will be able to easily give us different results. Also means that 5 is mapped to 1 in mode 2. 5 is congruent to 1 in mode 2. And you can just simply write it as this. And also 5 is congruent to 3 because the number at the top here is 1. 5 is congruent to 3 in mode 2 as well. Also, we can consider the negative values. This 5 is also congruent to negative 1. 5 is congruent to negative 3 as well. So even with the way we solve the other one and got 5 is congruent to 1 in mode 2 by division, because our remainder is 1, we can also still get this by simply doing what? By simply adding this mode, this value here to the number here. 2 plus 1 will give me 3. So I can say 5 is congruent to 3 in mode 2. So these two ways we can use that. We can also make use of the clock, okay, to explain that. Okay, let me just draw that here. I have clock, I have mode 2. Let this be 0 and let this be 1. Okay, this is 0, this is 1. So I want to know what 5 is congruent to in mode 2. So I will start counting from here. 1, 2, 3, 4, 5. So it comes back to 1, which is 1, means 5 is congruent to 1 in mode 2. 5 is congruent to 1 in mode 2. So these are 3 good ways in which we can solve this problem. Okay, B also, let's quickly solve B. So B is mode 3, B is in mode 3. So I can just make use of my number line now. Draw this. This is 0, 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, and minus 5. Okay, so the 0 map to 0. Now we are dealing with mode 3. This is 0, 1, 2. Mode 3 with 0, 1, 2. So this is 0, 1, 2. Also here, this is already 0. So this will be 1. This will be 2. This is also 0. This is 1. This is 2. Just like that. So we want to check what is 5 congruent to in mode 3. So we check the value at the top, what 5 is marked to. 5 is marked to 2. 2 is marked to 2. So we see there that 5 is congruent to 2 in mode 3. Also, we can also consider negative values. We can see that 5 is congruent to negative 2 also. 5 is congruent to negative 2 in mode 3. But we don't always want the negative, we don't always want it to be negative, our answer to be negative. So we don't basically make use of the negative, we just want the positive to be the answer. So I can say 5 is congruent to 2 in mode 2. Also, by the time we go on, we will be able to say that 5 is also congruent to 8 in mode 3. and so on. Okay, that is how we solve that. Okay, C now says that this is B. So C says that is 3 congruent to 5 in mode 3 is a question. Now that is 3 congruent to 5 in mode 3. So I will check 3 is mapped to 0, 5 is mapped to 2. No. So they are not taking same values there. So that simply means that 3 is not congruent to 5 in mode 3. So this explains basically how we deal with modular arithmetic, which is also known as our remainders arithmetic. So check the following class or the subsequent classes on modular arithmetic to get a better understanding on how to solve addition and subtraction of modular arithmetics and multiplication and division of modular arithmetics. Thank you for watching.